Hello everyone, welcome back to this channel. Till now on this channel we were solving the sliding window problems, and one of the problem we have solved in our last videos that was about longest substring with at most k distinct characters. So we just saw about the length of the substring in order to get the longest length of a substring. But what if I ask you to count the number of subarrays? So that is all about the problem, and the today's problem. So firstly let's read the problem statement and then we will move further. So the problem is about the subarrays with k different integers, k distinct integers. So the problem statement says is that we are given with an integer array nums and an integer k. Now we have to return the number of good subarrays of the nums. So first of all, what is a good array? So a good array is an array where the number of different integers in that array is exactly k. It means the distinct integers, the number of distinct integers, that is exactly k. So we will be given with a integer that is k, and for example, this is the example 1 2 3 1 2, and it is having three different integers. So we can say that 1 2 3, only three different integers are here, and a subarray is a contiguous part of the array that we already know. Now some two examples are given here. First example is this: the nums array is having 1 2 1 2 3 and k value is given as 2. So we have to find for all the subarrays which are having the k distinct integers. So we have to find for all the subarrays which are having the two distinct integers. So that count we have to find. That is the example 1 and same as the example 2. Now in the last video, the problem we have solved, we already know that how we have found the length of the longest substring. So whenever we got a particular window as the valid one, so we saw that okay, this is a valid window, so we can just take its length into consideration. So that will be the best length we can take. So we were just checking the best length out of it, and at the end we just updated, uh, like we just returned the lengths, and at the and for the same time, whenever the window is valid, we just updated the max length using the following formula. So this is just a recall we are taking, that we have just used this formula in order to take the maximum length using right minus left plus 1. That is just giving us the best length possible. But in the today's problem, we are not going to check for the longest one, but we are going to count for all the valid subarrays. So in this problem today, we have to count all the valid subarrays. Now for this, firstly let me take a simple example. Let's say we are having a window 1 2 1. Okay, this is a window, a valid window I am saying. And if this window is a valid one, then what are the number of subarrays which are possible? See, what the problem we have solved, that was for the AtMost key. And for the AtMost key, if a particular window is valid, we already know that if a window is valid, then for a fixed right pointer and starting from every left to that fixed right pointer, all these subarrays will be the valid ones, because we are solving for the AtMost key. So a subarray which is having one distinct will also be valid, two distinct will also be valid, k minus one distinct will also be valid, and k distinct, at most k distinct, will also be valid. So that is the key. So for at most k, if a window is valid, then all the subarrays which are starting from every left pointer to that fixed right pointer, all the subarrays will be the valid ones. So in this window, I am saying what are the number of subarrays possible. So one subarray is this, means, because we know that this here will be the left pointer and this is the right pointer. So from every left pointer to this fixed right pointer, all the subarrays will be the valid subarrays. One subarray is this, where element 1 will be there, only this subarray, and second subarray is this 2 1, and third subarray is this 1 2 1. What are the subarrays possible? Let me just write here. One subarray is 1, second is 2 1, and the third subarray will be 1 2 1. So these three subarrays will be there, and out of these three subarrays, because for at most k distinct, all these subarrays will be the valid ones. So therefore, if I have to count all the valid subarrays in the case of at most k distinct, then I can just count with what? Just I can take the count variable, and in that count I will just add right minus left plus 1. See, right minus left plus 1 gives us the size of the window, but at the same time it also gives us the valid subarrays, or the subarrays starting from every left to the fixed right pointer. So just having this count like this, right minus left plus 1, and I can just add that count in every time whenever I get a valid window. Okay, now this is we have understood that what we have concluded, that whenever we get a valid subarray or a valid window, we can get all the subarrays inside that valid window, and we can just count all those in order to get the count of all the valid subarrays, and just in the case of at most k distinct. Okay, cool. Now I am asking that if I am solving this for exactly k distinct, as in this problem we are solving for the subarray with k different integers, it means we are talking about the exactly k distinct integers. So can we say that can we count in this way, that we can just take a count variable, and whenever we get a valid window we can just count in this way, like adding right minus left plus 1 in order to get the valid subarrays. We cannot do that, because in the case of exactly k distinct, it might be possible that out of all the subarrays which are possible in that valid window, some of them will be the valid ones and some of will be the invalid ones. For that, let me take another example. So let me just call this as example 1, and example 2 I am taking one subarray. Let's say let's say a window is 1 2 1 3. So this is a window, and I am now again I am asking that what are the number of subarrays possible here. So one subarray will be this 3, another will be 1 3, then 2 1 3, then 1 2 1 3. What are the subarrays? 3, then 1 3, then 2 1 3, and another subarray will be 1 2 1. So these all are the subarrays possible. Now out of these, I am asking for k equal to 3. K equal to 3 means what? I am asking about the subarrays which are having the 3 distinct characters. Okay. So here I am asking about the exactly k, not at most k. For exactly k, in every subarray I must have the 3 distinct integers. So if I am asking about this one subarray, so this is only having one distinct, so it means it is a invalid subarray. Second is this subarray, it is again an invalid subarray because it is again not having the 3 distinct integers. This subarray is having 3 distinct integers, and this subarray is also having 3 distinct. Therefore, out of these 4 subarrays, these 2 subarrays are not the valid ones. They are the invalid subarrays because they are not having the 3 distinct integers, and these 2 subarrays are the valid ones. So therefore, what I am concluding from here, that out of a valid means from a valid window, there will be the multiple subarrays possible, not one subarray. But in the exactly k distinct problem, what happens is that some of them will be the valid ones and some of them will be the not valid, means invalid. So we cannot directly take a count and increment and just add right minus left plus 1, because right minus left plus 1 will give us all the subarrays which are in that valid window, starting from every left to that fixed right pointer. But in the exactly k distinct problem, what happens is that we are not getting all the subarrays as the valid subarrays. Some of them will be the valid and some of them will be the invalid ones. So we cannot use this logic in this. So what we will have to do is we will have to convert this particular problem into a simpler problem, or I can say transform this problem. So now we already know that how we have to solve the AtMost k problem, and in the AtMost k problem we already know that in a valid subarray, like in a valid window, all the subarrays are the valid ones, because for the AtMost k there will be one distinct also, two distinct also, k minus 1 distinct also, and k distinct also. So all will be the valid ones. But now as we have to transform this particular problem, so in what way we can think so that we can get to our result. Now because we want to solve for exactly k, okay, I am just saying that we want to solve for exactly k, and for exactly k means I want all the subarrays which are having the k distinct integers. So what I can do is, if I am saying that first of all we will get all the subarrays which are having the AtMost k, so this AtMost k will be the case where all the subarrays I will get where they are having AtMost k distinct integers. Means what are the things it will cover? This AtMost k part will cover the subarrays with one distinct, like I am writing in this way, means all the subarrays with one distinct, plus all the subarrays with two distinct, plus all the subarrays with three distinct, and all the subarrays till k minus 1 distinct, and likewise for k distinct as well. So in this particular case for AtMost k, I am getting all the subarrays with like 1 distinct, 2 distinct, 3 distinct, and k distinct. Now out of these, I also got the subarrays with exactly k distinct. So what I can do from here, that I can just subtract the extra subarrays, or I can remove the extra subarrays, like which are having 1 distinct, 2 distinct, and 3 distinct. So for that, what I can do is I can just subtract the AtMost k case here. So AtMost k minus 1. So what I am saying from here, that I am having all these subarrays which are having 1 distinct, 2 distinct, and 3 distinct, along with exactly k distinct. And if I remove this extra subarrays which are having 1 distinct, 2 distinct till k minus 1 distinct, and for that I can just do for AtMost k minus 1. For that I can solve in this way. So whatever the subarrays will be there for 1 distinct, 2 distinct, and k minus 1 distinct, those will be removed. Only the k distinct subarrays will be left. which I want as my desired result. So this is the whole intuition behind it. And let's just take a simple example in order to perform a dry run on this to get more clarity on this. So this is the simple example I have taken here, and let me just take a frequency map here. Now frequency map will be taken, and the name I am giving here frequency map. So we already know how we have to solve that most k problem. So first of all, already I am having this example and key value as 3. It means I want all the subarrays with exactly 3 distinct characters. So first of all, what I am doing here, firstly I will be solving for AtMost k, and then I will be solving for AtMost k minus 1. So what the result I want? I want the result for exactly 3. Okay, exactly 3 means exactly 3 distinct characters that all the subarrays should have. That count I want. And for this I will be solving for AtMost k minus 1, means sorry, AtMost k minus AtMost k minus 1, so that I can get my desired result. Now first of all I will be solving for AtMost 3. Now let's start expanding the window. Now first of all, this right pointer is pointing at this 0th index. So first of all, this one integer will come and come inside the frequency map. So it comes with the frequency count 1. Now we will have to check for the window validity. So we are checking for AtMost 3, means AtMost 3 distinct characters. So if this particular limit exceeds, then in that case this particular window will become invalid. Otherwise the window will be valid. So we will just take it into consideration. So right now this window is valid because it is having only one distinct character, one distinct integer. So we can just take it into consideration. Now this particular window is valid. So what we want the count of the subarrays. So as I already told us that if a particular window is valid, then all the subarrays which are starting from the every left pointer to the fixed right pointer, all the subarrays will be the valid ones in the case of AtMost. Here this particular window is valid one, so right minus left plus 1, that will be giving us the number of subarrays inside that valid window. So right minus left plus 1, how many subarrays will be there? That is only one subarray. One will be coming inside this and means added inside the count. So one subarray we got. Now this right pointer moves ahead and it checks for the another integer, that is 2. Now 2 comes inside the frequency map along with its frequency count. Now again checking for the window validity. So window is again valid because it is having only 2 distinct characters, but we want AtMost 3. So 2 is also valid, like 2 distinct integers. So this is again a valid window. Now again checking for all the valid subarrays. See, this is the window, a valid window, but all the subarrays which are starting from every left to the fixed right pointer. So this is the fixed right pointer. For this left from here, 1 2 is another, and is one subarray, and for this left from here only 2, this is another subarray. So means in this valid window 2 subarrays are there which are the valid ones. Okay, so for AtMost 3, this one subarray with one distinct, and this one subarray with 2 distinct. So these are the 2 subarrays we got. Okay, so for AtMost 3, this subarray for one distinct and this subarray for 2 distinct, we got 2 subarrays like this. So right minus left plus 1, what is the number of subarrays? These are the 2 subarrays. 2 will be added in this and it will now become 3. Now this right pointer moves ahead and it checks for another integer, that is 1. Now the frequency will be incremented for this and it will now become 2. Now again this window is still valid, and for this valid window all the subarrays, this one subarray with one distinct, this 2 distinct, and this is still having 2 distinct. So therefore right minus left plus 1, that will be 3. 3 will be added in this count and we got the 3 subarrays here. That will become 6 now. Now this right pointer moves ahead and it will now take this 3 and put it inside the frequency map. So it will now come inside the frequency map with frequency count of 1. And now checking for window validity. So because it is having 3 distinct characters, three distinct integers, so we can again say that this particular window is still valid. And for this particular valid window, all the subarrays, right minus left plus 1, that will be 4. So 4 will be added in this and it will now become 10. So till now we got 10 subarrays with AtMost 3 distinct. Now this right pointer moves ahead and now it will check for another integer, that is 4. Now 4 comes inside the frequency map. So 4 will be added along with its frequency count. Now because this particular window, entire window is not a valid window because it is having 4 distinct integers, but we only want AtMost 3 distinct integers. So therefore this window has to be shrinked, and that is with the help of left pointer. So left is pointing right now at this one integer. One of the occurrence of this integer will be removed, and now we will be checking the frequency of this particular integer. So it is not 0, so therefore it will not be erased from the map. Now this left pointer moves ahead, and once it moves ahead, now we will be again checking for the frequency map size. So again it is still 4, so therefore the window is still invalid. Now again one of the occurrence has to be removed for this particular feature where left pointer is pointing. One of the occurrence of this 2 will be removed, and because it is 0, it is having the frequency of 0. Therefore this particular frequency, this particular integer will be removed from the frequency map. And now this left pointer will move ahead and checking for the frequency map. The frequency map is now having the size of 3, so therefore this particular window is valid now. And because this is valid, so therefore all the subarrays will have to be taken. So this this right minus left plus 1, it will be giving 3. 3 will be added in this count, and the number of subarrays we got till now are 13. Now this now this right pointer will move ahead, and we will come to know that the window is no more valid. So therefore the process will stop for this particular case. For this at most 3 case, we got total 13 subarrays. Okay. Now we want to remove all the subarrays out of this which are having 1 distinct, 2 distinct, likewise, and we only want the subarrays which are having exactly 3 distinct. So for that we will have to remove that most 2 case, means which are having 1 distinct and 2 distinct. So now let's talk about the at most 2 case. So let me just take another map here. So this is the map, and let me just take it here, and let's keep this left and the right pointer at their correct positions. Now once we have done this, now again let's start to expand this particular window. So now the right pointer is pointing at this 1, so 1 will be coming in this map along with its frequency count. And now we will be checking for the window validity. So we only want at most 2 distinct. So here we already having 1 distinct, so therefore the window is valid. We can just take its count, increment this count to 1, because for this right minus left plus 1, it will be giving us the 1 subarray, valid subarray. Now this right pointer moves ahead, and it will going at this integer 2. So 2 will be coming inside the frequency map with its frequency count of 1. And now we will be checking for window validity. So again the window is valid, so we can just take all the subarrays from this valid window. That is right minus left plus 1, that is 2. So 2 will come here, and count will be incremented by 2, that will now become 3. So till now we are having 3 subarrays. Now this right pointer moves ahead, and it will check for another integer, that is 1. So 1 will be coming, and its frequency will be incremented to 2. And now checking for the window validity. So still the window is valid, and we can just take the number of subarrays from this valid window, that will be 3. So 3 will be incremented, like the count will be incremented, and it will now become 6. Now this right pointer will move ahead, and once it moves ahead, it will now take this 3 integer, this 3, and put it inside the frequency map with its frequency count of 1. Now still we can see here that the number of distinct characters moves, or we can say exceeded beyond 2. So therefore this particular window is invalid, and we will have to shrink this particular window. So one of the occurrence of this will be removed. It will now become 0, and it will now become 1, and because its frequency is not 0, so therefore we will not be removing it, and we will just take this left pointer and move it ahead. Once it moves ahead, we can just check for the frequency map size. So it is still 3, so therefore it is again invalid, and we can just take we can just again shrink this particular window. So we can just remove the occurrence of this 2, one of the occurrence of this 2, and get it to 0. Because it is 0, so therefore this will be removed from the frequency map. And once it is removed, we can just take this left pointer and move it ahead. And once it moved ahead, now we will be again checking for the frequency map size. So now it is having the size of 2, so therefore it is valid now. Okay, so this part of the window is valid. This is a valid window, and right now we can just take all the subarrays from this window. What will be the number of subarrays? That will be 2 subarrays. One is this 3, and one is 1 3. So we can just get these 2 subarrays and add it inside this count, so that will now become 8. Now this right pointer moves ahead, and it will go to 4. Now this 4 will be coming inside the frequency map, and it will be having the frequency of 1. Now again the number of integers, the distinct integers, are beyond this 2. So therefore this window is invalid, and right now we will have to shrink this particular window. One of the occurrence of this will be removed, and now because it is 0, so therefore we will be removing this 1 from the frequency map, and moving this left pointer ahead and checking for the window validity. So we can just check for the frequency map size, and it is now 2. So therefore this particular window is valid, and we can take the number of valid subarrays from here, and that will be 2. So this count will be incremented to by 2, that will now become 10. So therefore okay, and now this right pointer moves ahead, and because it is making the window invalid. So therefore we can just have the result as the 10. So we can just take 10 here, and now we know that all the number of subarrays which are here at most 3, uh, now all the subarrays are removed with at most 2. So therefore the exactly k distinct integers subarrays will be left, that will be the 3 subarrays. What is the result we got with the exactly k distinct, that is for the exactly 3 distinct, for the exactly 3 distinct we got the result as 3. So we got total 3 subarrays which are having the 3 distinct integers. Okay, so this is the result we got. Now let's get to the implementation part and implement it. Okay, so this is the function we have to complete. Now what I just told you, that we have to get this result for exactly 3 distinct. So for that we will be just solving for at most 3 and at most 2. Okay, and whatever the result will be coming, we will be just removing the extra subarrays and we get the desired result. So we have to just return this thing, at most 3 minus at most 2. So we can just write a simple return statement here about at most k, at most, sorry, that is at most, for the at most k minus at most k minus 1. Okay, this will be the case. Now we will have to write the helper function for this at most k case. Here int at most, and here we will have to just take this nums array, that is vector of, and we will have to take this nums array here, int of k. Then we have to take, now first of all let's just take the size of this nums array. So this is the nums dot size taken inside end. First of all you will have to just take the map, so that will be the unordered map, and will be int of int comma int, 2 parameters, because it is containing the integers, and that I will just name it as frequency map. And now let me just take the 2 pointers, left and the right pointers. These are the pointers I have taken, and one uh, one variable which I will have to take, that will be the count, in order to count the, in order to just return that number of subarrays. That will be int count, and initialize, let's initialize it with 0. Now we will have to just run a loop, while loop, where right will be uh, less than n. Once it becomes equal to n minus 1, means once it becomes equal to n, we can just stop this process, because at that point the window becomes invalid. Now first of all, whenever we are having this, we are just expanding the window with the help of right pointer. So we can just take this frequency map, and inside this frequency map, for this nums of right, I can just take this integer and put it inside the frequency map along with its frequency. Now once I have taken its frequency inside the frequency map, then what I will be doing, I will be just checking if the window is valid or not. So for that purpose, I will be just putting a case, means in case if this particular window is invalid, then in that case I will have to shrink that particular window. Until what point I will have to shrink? I will have to shrink it till it becomes again a valid window. So for that I can just put a while condition here, while loop here, and I can just check if the window, if the window condition is invalid or not. So for that, what I can see, I can just check for the frequency map size, frequency map dot size. If this is greater than k value, okay, if this value is greater than k value, then obviously that the number of distinct integers, that number exceeded the value of k. So therefore the window is invalid, and then we will have to shrink this window with the help of left pointer. So I can just take frequency map of nums of left, and for that particular integer I can just remove one of its occurrence, and after removing one of its occurrence, I can just check in the frequency map if the frequency map of nums of left, okay, if its frequency became 0, therefore I will have to just erase that particular integer from the frequency map. So that is with the help of frequency map dot erase, and that is nums of left. Okay, this I will have to do, and once I did this, after this I will have to just take this left pointer and move it ahead. And once I move this left pointer ahead, now what is the thing needed? Okay, So now what we have to do, firstly we have expanded our window, means I have just taken the integer inside my frequency map, and I have just expanded the window. Now in case if the window is valid one, okay, if the in case if the window is valid one, what I have to do, see, let's say this particular window is a valid window, and I want all the subarrays, because I know that this particular window is a valid window. So all the subarrays which are starting from every left pointer to the fixed right pointer, all the subarrays I will have to take. And how I can get all those subarrays? In the count, I will just increment right minus left plus 1, so that I can get all the subarrays which are having at most k distinct integers. Okay, so whatever the count I have taken, I can just take that count and increment this thing, right minus left plus 1 inside the previous count. Once I did this, I can just take my right pointer and move it ahead. So in this way, I can just take all the valid subarrays which are present inside that valid window. And this is I am doing for the at most k case. Once it is done for both the cases, firstly this particular function will be resolved, and once the result came, then this particular function will be resolved. And at the end, both of the counts will be coming, and the extra subarrays will be removed. I will get the number of subarrays for the exactly k different integers or exactly k distinct integers. And at the end, here what I will have to do, I will have to just return that count. Okay, so that count I will be just returning here. Now let's get here and run this particular code. Okay, so let's see here, map. Let's run this code. What's the problem here? Okay, so here what I have done, I have to give the nums array here, that is num. This is the I have done here, and I just submit it. Okay, so this is the solution for today's problem for the subarrays with k different integers. Now let's talk about the time and space complexity as well. So talking about the time complexity, here we are using that pointer, so two pointers. The right pointer is moving forward from 0 to n minus 1, that is for n times we can say. For the left pointer we can say at most it moves n times forward. So therefore the time complexity is O of n, that is linear time. And if we talk more specifically, so that is about for two functions, for at most k and for at most k minus 1. So that is for O of n plus O of n. That will be like O of 2n. So we just drop the constants. So therefore, the time complexity is O of n. And then talking about the space complexity in the frequency map, because the at most k integers are stored. So therefore, the space complexity will be O of k in this case. Okay. Space complexity will be O of k. So that is the time and space complexity in this case. Now, based on the same problem, this subarrays with k different integers, the same concept, the same approach has to be used in the another problem as well. That is about number of substrings containing all the three characters. And in this, we can just call it as a simple problem, because if we restate this problem, it is about the number of substrings containing the three distinct characters. So that is about just in place of k, that is more specific about k equal to 3, that is for three distinct characters, but it is about exactly three distinct characters. So we will have to again use the same approach and solve with that most 3 minus at most 3 minus 1, that is at most 3 and at most 2 case, so that we can get to our result. This is the same problem based on the same approach. So for this particular problem, I will just add its code inside the GitHub repo, and that I will provide inside the uh, description. And now in the next video, I will be solving another problem that is, I think, a better problem till now. That is a minimum window substring problem. And till then, just keep learning and keep growing. This is Aditya Patel signing off. Thank you.